Hello, everybody. Welcome to a new series of tutorials from Sound for More. It's Leo speaking. Today, I'm going to start a new series on music theory, which will guide you through from beginners to expert, I would say. I thought to do this for a long time, and I will monitor how successful it is on the channel and if to continue or not. But the purpose of the series is to actually give materials and help and support on understanding music theory and concept. Before I kick off, I would like to remind my viewers to subscribe as it helps with growing the channel. Thank you very much. It's a new series of tutorial on music theory, and I'm going to alternate between theory and using slide deck and also trying to demonstrate digitally, of course, some of the concept using miRack. Okay, so let's start. So what is at the basis of music theory? When we're thinking about music, we think about sound. So a sound that is generated and we hear it through our ears. So sound is all about vibration. It starts with an object which is vibrating, and that includes also, of course, movement of energy. As it vibrates, that object, it creates waves, and they are mechanical waves, and it is a physical process, as those waves actually travel through a physical medium, which can be solid, it can be water, it can be air, or anything else. And of course, at some point, that those waves actually arrives to our brain, and they are perceived therefore as a sound. So mechanical waves produced by a vibrating object traveling through a physical medium are perceived by our brain as a sound. Think about, for example, when you pick a string on a guitar. So as you have done that, which you do that, of course, through energy, through your hands, of course, as you're holding the guitar, the strings start to vibrate, and the vibration goes through the neck and the entire guitar. Of course, if it is an acoustic guitar or a classical guitars, then the sound will be reproduced through waves which travel through the airs and through the guitar hole. So that's just one example. Now, when we think about sound, now we know what it is and how it is being produced through vibration of objects. Of course, you can start sound in terms of when a sound starts, and you can also stop it, of course. And that leads to the concept of how long that sound lasts for, so the concept of duration. Therefore, it leads to the concept of timing, right? You can start at a specific time, a particular sound, and therefore you can then create a rhythm if you start and stop sound at different times. That is particularly the case when you have an instrument like drum. Further, if you think about those mechanical waves which are repeated over time and traveling through that physical medium, if one wave is repeated every second, it means that that wave has a frequency of what is called 1 hertz. And what you will find is that as that frequency on the number of waves per second increases, then you will perceive higher note, which relates frequency to pitch. This leads me to the explanation of what is an audible range. And for humans is between 20 hertz and 20 kilohertz. So for sounds which is produced below 20 hertz is called subsonic, and you don't hear it, at least from a human perspective. When it is above 20 kilohertz, is supersonic, which leads to an ultrasound. Okay, so additionally, the pitch is related to the wavelength. So the mechanical wave will have a start and an end. That would be, if you measure that in terms of time, that will be your wave length, of course. And if you think about when you go to a studio and you turn on the volume on a mixer, you find that the sound gets louder and there are more stronger vibration which are coming out from your speaker, which produces the sound which we perceive in our ears, and that increase of loudness is measured through amplitude. Lastly, I want to also start the introduction of what is called noise, which is practically a sound, but it's a sound which doesn't have a clear or perhaps stable or recognizable frequency. Okay, so with that being said, let's move to miRack. Okay, so let's double click on the screen and let's introduce a VCO, which effectively is a digital representation of an object vibrating and producing the four waveforms, as I just explained. Let's double click again on the screen and add these oscilloscope. And we will use these to represent the output graphically, what comes from this VCO. So let's connect, click and drag, and the up here. So you can see now a waveform which is repeated multiple times. This type of waveform is a sine wave. Now, as you see here, there is a dial, and this dial is used to increase or decrease the frequency. And look what happens when I'm decreasing the frequency, right? So the waves get wider. So, and the wavelength is measured from this point here to this, because you can see that after going up and down, it repeat again. Of course, you can measure the wavelength in a different way, for example, from this point to again when that point repeats as well. So as you can see now, if I decrease this down to a very minimal, you'll find that it almost shows one wavelength, which would be 1 hertz. And you can see also here a notation which says that C4 is equal to 261.63 hertz as well. So it's just another example how we correlate the frequency to pitch and also to our notation. Okay. Now, if I was to connect these to the output, so you can start to hear some sound. You'll hear that sound, and I'm going to increase the frequency. You'll find that it will increase the pitch. What you also notice that when it is very low, the pitch is started to get to the point where you can't hear, can't really hear the frequency. Now, let me show you something else as well. So I double click on this module and select manage and then delete. Double click on that again on the screen, and let's introduce a frequency and modulation operator. And again, don't worry for now how everything works. But the reason I'm introducing this is because I have the ability here to set the envelope, which allows me to adjust up and down the amplitude of the waveform. I said earlier that the louder a sound is, the higher the amplitude is. And the amplitude, again, here you can change the frequency. Let's decrease, and let's remove the envelope for now. Okay, let's decrease the frequency like that. So the amplitude is measured from this point here up to here, right? So your signal is going up to this level, so that would be your amplitude, okay? And in this case is positive, and in this case is negative, depending of course on the position and the axis and depending on voltages as well. Now, let me show you that I will introduce some envelope, so the ability to control how fast the sound goes up in terms of amplitude, which is called attack, how fast it started to decrease that that amplitude, and when I let go and I don't produce anymore, don't ask the module to produce anymore that sound, it will slowly release the amplitude down to a 0 level. I'm going also to add a 12 key keyboard, and I'm going to quickly connect it like so, because I want to drive some notes. So I'm going to make the connection here as well in the output. Okay, let's press here what is on F. Now, can you see that the amplitude is coming down? And to show you better, I'm going to increase the release a lot. Look. See, the amplitude is coming down. It gets less louder to the point that it's the zero, and then you don't hear it anymore. So hopefully that showed the example in terms of amplitude as well. Also here, you can see again that we have a keyboard and we have a selection of what are called octave. I can go up an octave or lower an octave, so I can go higher up with notes and lower. So if I press an F here, you see how big that waveform is. If I go lower, it starts to get even bigger, which is the same point that I explained earlier with lower frequency, and for lower pitch, the waveform becomes bigger. Okay, I'm going to stop here for this first introductory tutorial or lesson. I hope you like it. Please leave feedbacks if you find this useful, and if I should continue to go through additional tutorial and go into more, I suppose, expert topics and progress through the explanation of more attributes related to sounds and even including music notation, etc., etc. Okay, I see you next time. Thank you. Bye.